Hi, welcome to welcome to the first Open Security Summit session of the December virtual event. This is very exciting for me because it's a great session that covers some of the things I'm most passionate about, which is threat modeling, graphs, visualization. So it kind of doesn't get better than this. You're going to see some of the amazing work that the team that I'm privileged to work with at Glasswall is doing. And most importantly, please join in and participate in the conversation of kind of how to scale, threat modeling, right? How to scale the creation and especially dynamic generation of graphs and basically visualizations for threat modeling. And I view that this is just the beginning of a lot of great sessions. And again, for reference, the summit, it's all about open stuff. We respect everybody be, thoughtful in how you participate, but also we're doing this every month. So we're going to have another set of sessions in January. So, if you have follow-up ideas and topics, please let's continue then. But also there's a Slack environment, which I believe the link has already been pasted on the Zoom here. So, please join in and be involved. And over to you. I think Baker, you start.
Yes, thank you. My name is Lwasampijja Baker, and I'm going to take you through threat modeling, but my part is going to deal with PlantUML. Okay. So the idea behind this talk is purely how to get from here to something like this, but using code. And in this case, we've chosen to present PlantUML because it is great, as you are going to see in the next slide. So basically, PlantUML is a component that allows you to quickly and simply draw UML diagram using a simple kind of syntax, as you're going to be seeing. For example, this syntax, boy, the relationship to a girl, and then that's love, that purely gives you a diagram that goes to this side. And when you look at the relationship, for example, between a girl going back to a boy, of course, she will not have any of it for now, but you can clearly see that just a simple syntax like this will give you a diagram like that within a couple of minutes, which makes it really, really good and very easy to start using. So we chose to share PlantUML because, like you've seen, or like you will see, it is very easy to implement. You can work with it in multiple environments that you are already accustomed to. And drawing diagrams using code is always easy to maintain. And you can actually draw all the common diagrams, the UML diagrams, the sequence diagram, the class diagram, the activity diagram, all kind of diagrams. You can draw all these using a PlantUML. And you can also track changes. Let's say you created your image. Then, for example, version control, like using GitHub, the moment you submit your code and then you submit another version of the same image, you'll be able to know how your image has evolved over time. And lastly, PlantUML is free to use. So that's why, so I've tried to share links when you get the presentation. I've tried to share links on how you can integrate PlantUML in most of these common editors. You can use it in your Jupyter notebooks. You can use it in Ellipse. You can use it in Visual Studio, in Atom, in PyCharm. In almost all these environments that you are already accustomed to, you can use PlantUML. If you don't want to install anything, there are also other PlantUML editors that I've shared. So you'll be able to check those out and then see how to get started. So I would talk about the C4 model. I don't know if most of you are familiar with the C4 model, but there was an integration between the C4 model and PlantUML by Ricardo to give us a way of creating better images and better models, as you're going to see. So for example, this is purely an example of a model that is done in PlantUML in addition to the C4 model. So they are also standard libraries that have been developed by different individuals.
Sorry, Becky, could you just go back a slide?
Okay.
So
yeah,
this has been generated programmatically, right?
Yes, it has.
Yeah, I think that's very important, right? I think it's very important that, you know, the stuff that we're showing you here is being generated from code, which actually means that when, you know, one of the next phases of this, I would say this activity is to actually generate this programmatically, even from live codes and live systems. So for example, you know, what you're seeing here, just for reference, is the ICAP solution, basically, which is Kubernetes-based solution that we're working on at the moment. You know, all of this is defined, for example, in the Kubernetes manifest and Helm charts. So each of those boxes is actually a pod. So eventually we should be able to programmatically create these diagrams, which actually will reflect a particular version of a particular installation, which is where this will really scale.
Yes. Thank you. Now, there are these standard libraries in case you need to use different icons from Adobe Web Services, from Azure, from the Kubernetes, and then others. You'll be able to use icons to make your image or to make your model even look better. Like this. This is an example of a model that incorporates in all the icons from the different standard libraries that you have. And it has been generated by PlantUML using code. And this is what we are going to see. How do we get started to develop something? This is a little bit of a kill, but we'll start with the simple things, and then we see how you'll be able now to generate such an image using code. So for the simplest implementation, I'm going to demonstrate how you would get started when you are working in a Jupyter environment, a Jupyter notebook. So you would just install iPlantUML, and then you import it into your notebook. So once that is done, you will start it. You start PlantUML. The code that starts PlantUML, sorry, is start PlantUML, and then at the end it will end PlantUML. Since what I want to demonstrate here deals with the various standard libraries, you would need to call onto those libraries. So the link here, I'll share the code also at the end of the presentation. So the link, you define the icon URL that will call onto this standard library. And then this will call onto the Azure PlantUML library. And then this will define the Kubernetes PlantUML library. So also we want to import the C4 model into, because now the C4 model comes compiled in PlantUML. So you don't need actually the link. You can also just call it like this, and then it will show up. So the C4 models already comes with custom-made entities that you can always use and customize. So for example, if I call a person, I'm declaring now the entities. This entity is in terms of a person, and you give it an alias and what you would see here. And once I run that, that will give me this entity. The other great thing is that you can also fork this repo and then create your custom kind of entities with the visualization that you need, so that you can continuously use them. So the system will give me this, and an external system will give me this directly from the C4 model. So now I start, after I've declared this, I've actually chose to change the color of the external system here to red. And this is all you have to do. You just have to declare the color here, and then that will be, it will become red, or to any color that you want. Now, the relationships or the connections between the different entities is really very easy. So you just call on the alias like you declared up here. And so, okay, the personal alias will go to the right, and then it will go to the system alias. And the explanation of that is login. So this relationship will give me what you see here. Person goes to the system, and the action here is login. So another demonstration here is the external alias that I declared here. It will go up to the system alias, and then the action is attack. So basically, with this simple syntax, as you see it here, I've been able to draw up this diagram. We continue. Now I need to create some of these. Sometimes we have boundaries that we want our components or our entities to be in. So the way you create a boundary is you declare a boundary here, and this is a C4 item. You give the boundary an alias, and then you give it a name that will be displayed, security system, and you can clearly see it here. So the moment you open that, you now put your entities, all of the entities that you want to show up in that boundary, you put them inside the boundary, and then you close it. The relationship keeps the same, but you can clearly see down here that we've had a boundary added to our components. So then now I will introduce you to using the standard library. So I've also gone ahead to give links to these different libraries in these pages. You'll take time to look at them. But basically, once you open the page, there are so many icons that we can choose from. So at the moment you find the diagram or the icon that you want to use, what I do is that I copy the description of all, because I might need to use more of these same icons that belong to this same class. So, and then I copy the description of the icon that I want to use. And how do I implement that? So for now you import the Amazon Web Services icons. You always have to include a common syntax and then simplified, and then you call onto the class of the icons that you've chosen. So I've chosen the database, and I'm going to take all of them in case I need to use more. So that when I come here now to describe, I call the description that I copied, you give it an alias, and then you give it a name that will show up. And when you check our presentation and the image that comes up here, you'll see a nice diagram shows up right there. And then that is how I added. So basically we follow these same procedures when you want to import Kubernetes icons or Azure icons. You just call them using the same format, go and pick the description of the icon that you desire. You come to your code, write the description here. You give it an alias and give it a name, and then you will come up with an image just like this. As you can see, this is the Kubernetes icon, how it looks. And as you can clearly see, our diagram or our model in this case is starting to take shape just using simple lines of code. The next one are the font icons. Again, we follow the same. You call the library, you declare the statement. I mean, you declare the icon that you want to use, you give it an alias and the name that will be distributed. You can even change the color. Voila, it gives me that particular image. So what I've seen that is most important, there are a few things that you might want. Sometimes you need to create a relationship between an image or an icon with another, and it's not seen. You can use the hidden arrow. Sometimes you might want to incorporate images into the model that you are building. You can always use this syntax. There is a no direction syntax, or you want to make a double arrow. Sometimes you might want to have arrows that are dotted. So these are simply some of the few things that you can use to come up with a nice image. So with this, I'll take some questions and then proceed to give you a slight demonstration. Are there any questions at the moment? I have a few minutes to spare.
So Baker, how easy is it to write that code? I mean, you know, you presented this to us before, and it just scaling it up. I mean, I know it's great in scaling in a way, but how easy to, like, you know, for non-technical people, let's say, people who don't have development background to implement this?
Yes, so the syntax is really straightforward. The moment you learn the basic syntax on how you declare your entities, the relationships are really, really easy. You say left, it will move to the left. You say up, it will. So you just have to take a little bit of time, understand what the syntax looks like and how it is implemented, and then you will come up with an image with no time.
And how easy is it to scale it up? I mean, because I know last time we were using this and we had a change in the design. So how easy is it, like, to implement changes?
So because the arrows are drawn programmatically, you really don't need to move the icon. And this is the beauty about it, is that you can withdraw an entity from the diagram. The moment you withdraw it, the other arrows will fall in place, depending on where you need them to go.
I think what it would be good maybe to address is maybe Baker, you or Dinis have like a solution for PlantUML can be buggy sometimes in a way that, like, if you introduce a new relationship or a new element, the whole diagram can sometimes shift upwards or shift lowards without having any explanation why. So I was just wondering, do you have maybe going forward, like when you start having like really complex diagrams, do you have any solutions for how to address this problem?
You are muted, Dinis.
Yeah, Dinis, you're muted. Dinis, you're muted.
Oh.
You are muted, Dinis.
Oh.
Dinis, I think that you lost the audio. I don't see the audio connected.
Yeah.
Yeah.
Well, while Dinis check the audio, we cannot hear you. Also, we have another question from Mel asking, where is the best place to find more information on developing C4 models?
Oh, it is c4models.com. Let me share the link straight up into the chat. All right, so that is the link. So I had 20 minutes. My time is fast spent. I don't know if I have time for a slight demo or what I presented can go so that we can move on to the next presenter. I'm wondering.
You can present the demo if you want.
Let's go ahead.
All right, let's have just a slight demo to have a feel of how this works. Okay. Okay, let me share something. So I'm just going to use this for basically demonstrate a few things on how you start to declare. So for example, if I have another rectangle, this is a web-based text editor for PlantUML. You can check it out. I sent the link. It's really good. It gives you some of the things you can do. For example, you can declare a header, you can put a footer, you can scale your items and everything. So if I declare another and I call it, for example, left and Control Enter, it will create another box. Oh, rectangle. Oh, there is an L missing, sorry. So if I do that, and then the relationship, just to could say that, for example, from arrows, you go to left, you can use this, or you can just use L, and then it goes to left. Of the norms I'm not confusing. And then it will go left, and then you could also describe the relationship that is moving left. And just doing that will give me something that looks like that. Purely easy to grasp. So if I could have maybe another rectangle, and this goes down because this is something of, this is bottom, for example. And I enter, it will create, keep missing up the rectangle. Okay. And then if I could have from arrows going down like that, you will see it goes to bottom, what I declared up. And then if I don't want to describe the relationship, I just move it like that, and then it will give me something like this. So as you can see, within no time, you can actually create these images really, really fast. So maybe I would demonstrate one, how we get a live icon, like I demonstrated in the presentation before I can close. Yes, so I'll just copy paste to save us from some time. So I'll use the libraries, and then I'll use these libraries here. And as you can see, if I put it up here, so can you see this page with the icons?
We see the C4 model page.
Oh, okay. So here are the symbols that you can literally pick from. They are very, very many. And then you just have to choose which one you want to take. So let's say we want to take this. So I'll copy this because it will give me access to all these icons that are below here. So if I'm to take that, I would come here and then include it here, but also put the path that I declared up there. So I want to create that entity. So I copy the description of that. So it is called AppSync. So once I do that, I'll be able to paste it right there. And then I give it an alias. For example, it is my app. Okay. Let me see what we need. And then, where are we? Yes. So I'll give it a name that I want to be displayed here briefly. So up, like that.
Auch einschlägige Szenetreffs, ich kann es nur immer wieder empfehlen. Ja, sich vernetzen, sich kennenlernen.
Oh, okay. So I'll give it something that is empty. Oh, clearly it's not working. Oh, something. Let me just copy this.
So whenever you do demos, right? Always works when you do it at home, but never works on a demo.
True. So what do I need? I need something similar to this. Let me just copy paste this here. And then I change my sync here. And then I can name it really anything that I want. Oh, something is terribly wrong with this one. Oh, it's not closing here. Okay. And then it will give me that icon, as you can see it right there. And then I can just give it a direction. Let's say it's moving from bottom. Bottom. And then it goes to the left. Sometimes you really might not have to. And then I called it that. And then it will go, the naming. So I call it up. And then I call it up. And then that will give me something like that. I don't know why it's not loading. So basically, that would be the process of starting your way around creating different diagrams. I don't know if you can have any more questions. Or
Thank you, Baker. Does anyone have any questions?
Okay, I'll stop sharing.
Thank you so much.
And then Lucía can continue. If there are questions, I'll be on the chat and I can tend to them as they come.
Okay,
Yeah.
so let me share my screen. Oh, I can. Give me a minute, please. Okay. Okay, so I'm Lucía, and I'm going to show you how to use VisJS in Jupyter Notebook. So VisJS is a dynamic browser-based visualization library for JavaScript. It is used to create timelines, 2D and 3D graphics, and what interests us today, customizable networks. So
Can you hear Lucía, Baker?
do you hear me?
Yeah, now we lost you for a second.
Yeah, we lost you for a second.
But you heard this part, right?
Yeah, probably you have some network problems. If you can turn off your video, that could help.
Yeah, I will do that. Give me a minute to find here, stop video. Okay. So, okay. Okay, so first we need to get all set up. And here are some steps to use VisJS in Jupyter Notebook. These instructions can be found in this repo here. So first of all, you need to have Anaconda installed and then download this package and unzip it in the desired location. And finally, create this script inside the Jupyter folder and add this line with the path to the folder where you unzip the package. And the next time you start Jupyter Notebook, you should be able to use VisJS. Okay, so now that it's all set up, we can start working with VisJS. We also need to import these packages. And this function will help us to hide the code in the
Maria, I think we lost you again.
Yeah, we lost you.
So here with the show or hit the, okay.
Lucy, I think that you are having some network issues, so probably you can send me the URL and I can share my screen. We can try that.
I think that's a good idea. Maria, if you give it to Georgina, she can share the screen and you can just talk without the screen being shared, because that takes a bit of your bandwidth.
Yeah. Let's try that.
Mm-hmm.
Okay.
Hello, I'm back. I just got disconnected.
If you share, Georgina, your slides, then she can do the screen share while you talk, because sharing the screen is probably taking too much of your bandwidth.
But I have to show stuff in the notebook, and it's not only the presentation.
Okay, you can try.
Let's try it one more
again.
time. Yep.
Probably let's close videos if you don't mind, guys.
Yes, I will close the video. It is closed.
We can all close the video.
Okay. Yes, please.
Baker and Chris, if you'll close the video, that might help.
Okay.
Thank you, everyone.
So what was the last thing you heard?
Yeah, right here.
Okay. Okay. So we can show or hit the code with that. Okay. So here the code is hidden, and we'll see a simple example on how to create this network. This network is a reference to interpret the threat model workflow. So the HTML code and the JavaScript code must be in different cells. So let's inspect the code. This is the cell for the JavaScript code. So we define shapes and colors as variables. And we also create a set for the nodes and a set for the edges, right? And each node has an ID and a number. And to define an edge, we must specify from which node ID to which node ID we're going to. So, for example, here, let's see the code, and this is the network. And if I change here the ending node, the network will change this way, right? So I will change it again. Okay. And we can also specify other features like label, color, like label, color, and in the case of node, we can also choose a shape, and in the case of edges, if it has a direction.
Hi, team. I'm back. One of the coolest things of this is the fact that you could see that, you know, we're now very close to being able to automate this, right? Because this is very code friendly. So as long as you can create code that spits out nodes and edges, which is very compatible with, if you use other graph databases like Node.js, Neo4j, or Gremlin stuff, or other environments that give you a kind of nodes and edges, or Network X for Python, or even just a spreadsheet, right? Or Jira, function, right? And it's almost like even JSON, you can basically start to create these nodes and edges from it, which is really cool.
Yes, I will talk about that now. Cool. So finally, we define the network, and to create the network, we need a container. We need a data with the set of node and edges, and we can also set some options, right? So for example, here we enable the hierarchical option with the left-right direction. And notice there is also an option called physics. We will enable it in next examples. Okay, so now regarding what you were just saying, Dinis, so in order to create a network visualization of the threat model, First, we need to pull the data from the tables in the Google Spreadsheet and convert it to a Pandas data frame. So this is the spreadsheet with the threat model. And
yeah, to maybe provide a bit of context, the threat model was done by the security team. This was just the first pass at the threat model. Now it's outdated, but it's a good use case for an example, because what we've done is we've created a spreadsheet with all the possible threats, threat actors associated with it, vulnerabilities associated with it, and then each vulnerability has its own risk and risk assessment. So basically we needed a way to visualize this, because as you see on the spreadsheet, it's quite messy. So hence we were in the quest to kind of create a diagram from this all to see all the relationships that we have from all the assets to the threats to the threat actors, because obviously all the vulnerabilities are not, there's no point just listing them. It's better if we have it in a relationship to other things. And it's great if we could visualize them. So hence we kind of went on a quest to find the best way to put this in a diagram, and which would scale so that if we need to add more threats or more vulnerabilities, then that can be easily implemented in code.
okay.
Yeah, carry on, Maria.
Thank you. So this is the table we will represent as a network, and here we have the references of what ID means. For example, TV01 would be ICAP client, ICAP server, and so on. So we pull that data from the Google Spreadsheet into a Pandas data frame, and then we convert it to a JSON file. We are currently working on getting the data for nodes and edges from here, so the network can be dynamically updated from the Google Spreadsheet, right? So if the Google Spreadsheet changes, the data frame we pull changes, and the JSON we generate from it also changes. Okay, and with that information of the nodes and the edges, we will create the network. And we made two representations of the threat model, one with a hierarchy and another one without a hierarchy. So for the first option, we enable the hierarchical peel here with the up or down direction. And notice that the physics field is still set to false. And if we go to the notebook to see this example, here, this is the network. We can zoom it and we can move across. And we also use different colors for the edges to show the path it follows. So it goes from here to here to here, following the red path, and the same for the other colors, because some nodes are repeated in the paths. Okay. So now let's see the second option with no hierarchy. In this case, we divide the nodes in groups so we can format them by groups. So, for example, all nodes that are in the trust boundary group will be blue and with a circle shape, and all nodes that are in the risk group will be yellow and with a rectangle shape, and so on. And notice that now the physics field is set to true. So let's see what happened in the notebook with that option enabled. And here, this is what we can do with that. We can move all the nodes and put it in other directions. Okay. So finally, I wanted to show you this example. So we can see how is the code to pull the edges and nodes from a JSON file. This will be the function that do that. In this case, is taking the information from this JSON. And this is the network we get. Okay, so that is all for now. Do you have any questions?
We have one question from David. He's asking if someone has created these diagrams for Kubernetes Helm chart.
Oh, I don't know, maybe Baker or Chris. Do you know that, if they can be created for Kubernetes? I'm not currently using Kubernetes.
Well, that's one of the things we're going to work on next. Who asked that question?
I asked the question.
Cool, let's work together on it.
I also have a colleague doing threat analysis using Archimate diagrams, and he's doing the same thing. Like
Cool.
you do.
Let's share information, man. Like let's collaborate, right? So basically, literally, one of the next steps of the project that we're working on internally, which actually it's all on GitHub, right? It's actually an open source project. It's going to be to visualize Kubernetes. So let's work together on it.
Okay, cool. Sounds cool. I want to learn Kubernetes.
Do we have any other questions for Lucía or for Baker?
Well, what do you guys think, right? From a scalability point of view, have you, and I guess maybe one question I had for the group, right? You know, have you seen other alternatives that, or visualization in engines or tools that are similar to this that we should be taking a look at?
Yes.
Yeah, it's a package called GraphVis. Yeah, I used to use that one. I think it's simpler, but it has less functionalities like. But
yeah, I know GraphVis is a good option.
And my colleague
is Dot.
My colleague is doing with Archimate. So he's using Archie to design his architectures, and then he has extended the Archimate language to do his threat analysis on the Archie models.
Can you have a link that you can share with that? I can see Archimate modeling. Is that what it is?
Yeah, that's to do the only the architecture stuff. But he's doing that in the SAPSA. I can maybe send over I can speak with him at least about and sharing his knowledge about these kind of things. But Archimate is used for architects to model their, to make their architectures on it. And he has extended it to do security analysis on it.
Yeah, I like it. Yes, looking interesting. Yeah, definitely take a look at it. Right. I guess, yeah, interesting to see how they, because it's all about, my view is like, as long as we can get the data into a kind of a JSON format, then it starts to scale, right? Mm-hmm. And in fact, the other thing that, the team is going to be working on next is actually starting to use serverless functions to render the images. So we can put these as part of CI workflows and pipelines and then almost start to lock the images, because that's also very important for future reference, but also to do analysis. Cool. And then the security team is going to start to add other types of analysis and visualizations and simulations on this data, right? Right, Petra?
Yeah, definitely. And there's also potential in the fact that there is like you know, the fact that it's a JSON file. So JSON files are quite universal, and like there's the potential that we could create, like Maria was saying, we can even have just a simple spreadsheet instead of, you know, going all the way through and creating a UI, and just having a simple spreadsheet that we update, and we can get, like, you know, we can get anyone to update. Basically, you don't need any specific skills, and then that programmatically gets translated into a JSON file and goes into a diagram. So that can be really good for scaling, because any change that needs to be added simply goes in the spreadsheet, and that just automatically creates the diagram. We don't need to worry about the relationships or anything else.
Yeah. Although I would say that you really want the data on a spreadsheet to be stored somewhere else as a main store. But as an intermediate representation to edit stuff, spreadsheets are really good.
Yeah.
Well, actually, I just got a question from Twitter. That's cool. It says, is the hierarchical information intrinsic to the graph data, or are you projecting something onto the graph? When you look at the hierarchy, so actually, yeah, if you go back to the Lucía, can you go back to the thread model visualization one, the option one? So I think the question here is, yeah, the hierarchy is determined by the graph data, right? If you go to the one above, no, not this one, the one above.
Yeah, I'm trying.
Yeah, the hierarchy is determined by the flow, by the data, basically. Because we talked about, before creating this graph, we talked about where do we start, like what is the highest point of the hierarchy, and then we worked out the flow.
Yeah. And this graph here shows the workflow. So this is the same hierarchy, but left to right instead of up.
By the way, you guys know that in PlantUML, you can tell it which column to add the data, right? I don't know if Baker, you play with that, right? You know, in PlantUML, you can actually tell there's an option to determine like which row or which column to actually put some of the nodes.
Yeah, you can do that.
Yeah, so that will help to say, for example, the actors only show in some area, the threads only another one, and another one, and another one, right? And I think on VJS, what the trick I've used in the past was to pin, you know, certain types of nodes. So I did this graph once where I had all the risks and vulnerabilities, where I had the top level risk at the top, like R1, R2, R3, R4. So R1 there, who link to an R2, to an R3, to R4, and then links to vulnerabilities. But then I will link the bottom of the vulnerabilities at the bottom of the graph. And then you actually had this really interesting sort of top-down, almost a map, right? But at least the graph top-down, where you had all the risks at the top, and for example, all the vulnerabilities at the bottom, and all the graphs in the middle. So you could do one where you put the thread agents, or you know, of some assets at one place, and you can lock them in, because VisJS is just a canvas, right? That is literally just HTML5 canvas. So you can draw all sorts of things on top of it, which is really cool. All right, good stuff. So what we want to see is, you know, there's a channel for this, right? Sure, there should be a channel on the Open Security Summit. You know, everybody, you know, if you're interested, please, you know, join in there, right? And I think, Petra, the question here is, how can we make this scale for you, right? For your team.
Yeah, I think we can start with the Google spreadsheet, even though it sounds very simplified and not too posh, but I think it's a great start.
Can you guys share the link to the repo, because this is already open source, everything that you guys seen today?
Yes, sure. The link is in the presentation, but I will share it now here in the
just
chat.
put it on the.
I still have to make a pull request to have the last version, but I will do it soon.
Yeah, but if you put the link, you know, that eventually that will be there, right? But just put the link so that you know, people can find it.
Okay.
Cool.
There, I put the link in the chat.
Cool. Yeah, and please provide feedback, right? Like, the way I look at it, this is a problem that we need to solve as an industry, right? So, let's collaborate, let's find ways to scale this. And what I think we really powerful, and actually maybe for this team, what I'd like to see for the next session next month, right, is already start talking about specific case studies. So basically say, here's a web app, here's an MVC app, here's a desktop app, here's like, for example, I don't know, password reset, whatever. Let's look at specific scenarios, which actually are relevant to us. So we already can do that, but also with the community, so that we can start to look at them as patterns. And there's also like the threat modeling cookbook stuff that has been published in OWASP, which again is a really great resource. So we should be trying to replicate those, these kind of graphs and diagrams, and figure out the best way to make it work with a Google Sheet or with YAML files or with Jira or whatever database we use. It'd be really good to do that. Cool. And okay, nice comment from Ronnie. This gave me some great ideas. I love the idea of a spreadsheet template to generate JSON. We can then be renderings. Yeah, it's pretty cool. And then you can bring it to a pandas notebook, right? Which is what you guys doing.
Yes.
I can add also one thing that JSON files can be used for, which is, if you got someone with kind of a bit of a data science mind in your team, you can, all of this, if you use JSON files, can later be put into also machine learning algorithms at a later stage. So it has some cool potentials in the future. You just need to think of is there any problems that, in your threat modeling machine learning could help you solve? And this as a JSON file can also be something that machine learning models can digest, along with pandas data frames.
Yeah, pandas is awesome, right? Pandas is literally like a great place, especially when you start to bring multiple data sources together. It really makes a massive difference. But we do need to start running this in serverless environments, because it makes a massive difference, and also scalability. Cool. Here's a good question. Actually, we have experience on this, right? What kind of experience are people having promoting adoption amongst teams outside security, primal developers and architects? Go on, Petra. We've been doing that.
Sorry, can I get that question again? What kind of experience are people having promoting adoption among teams outside security?
Oh, I would say these ideas, right? Threat modeling
adoption,
ideas,
you mean of threat modeling? Is that the question?
Yeah, pretty sure, right?
Well, specifically, I was thinking about this kind of tooling and approach. We can, as security practitioners, start, building all our own stuff, but we get more synergy when we engage other teams, on the same approach.
Yeah. So in regards to building data flow diagrams, we had a great cooperation with developers, the architects of the solutions that we did the threat modeling with, because the way we presented it to them was like, well, basically you're the architect, you know the architecture best, so you will know the data flows, and we made it as a cooperation. So because they also knew that if we found something on the threat model that would need it to be incorporated in the architecture, they would be the ones changing it again. So they, in a way, they kind of had an interest to participate in all of this, because if we would find something that needed an architectural change, they would be there already and kind of thinking in advance how that can be implemented. So that's one thing. The other thing is this kind of approach, with Excel spreadsheets, it's very easy for threat modeling sessions. So we done a threat modeling session with with the architects of the solution. And, when you're doing this on the spot, it's quite easy just to fill in a spreadsheet with all the possible threats that we come up on the spot. So that also helped, because if we have a live session where we kind of complete that spreadsheet, and then all we need to do afterwards is just let a code digest it, then that's also very helpful for the whole cooperation bit.
I have one addition as well, that having that security champions program made people like, made our relationship as a security team with other teams really, really good. And let's say the architect who was working last person we were working on a threat model with was one of our senior architect, and he's a security champion. So I just want to say that helped a lot. I think what we have a glass wall between Touchwood, so between the developers and security and so the security team is something like I haven't seen in any other environment I worked in. That is that.
All right, and with that one, I think we actually just realized I think we need to wrap up because there's another session that is about to start, and I realized that we were using the same Zoom session. So thanks everybody.
Thank you everyone.
And
all right,
Georgina, you can stop the recording.
Thank you. Bye-bye.